Hello, I'd like to review some of the key equations for confidence intervals. Prior to examining the equations, I just want to review the process of inferential statistics. We're typically given some population that we wish to learn more about. The parameters, such as the population mean, mu, and the population proportion p are typically unknown. And most likely we would like to, at minimum, estimate these values. To accomplish that goal, we collect a random sample from the population that is representative and free of bias. Using this sample, the data we collect in the sample, we compute statistics such as the sample mean, x bar, and the sample proportion, p hat. Combining the statistics with a probability distribution, we can perform computations that will allow us to estimate these parameters with a significant degree of success. Let's now take a look at some of the key formulas. So one formula is to estimate the population mean when the population standard deviation sigma is known. In this scenario, we have our sample mean x bar, and we're adding and subtracting the margin of error. The margin of error is defined as z, these are your z values, sub alpha over 2 times sigma over radical n. We're adding and subtracting that quantity to the sample mean. Sometimes we have to estimate the sample size. To do so, we have to use this formula. N is z sub alpha over 2 times sigma divided by e. E is a given margin of error. It typically follows the words within. And don't forget to round up the final answer to a whole number. Another variation of the confidence interval for the mean is when sigma is unknown. If sigma is unknown, and typically n is a smaller number, the sample size is a smaller number, we replace sigma with s. S is the sample standard deviation. And we use a t distribution in this to estimate mu. So the formula is x bar on both sides plus or minus the margin of error, but now we're using t sub alpha over 2 times s over radical n. Next, we have a confidence interval for a proportion. So P stands for the population proportion that we're estimating. P hat is the sample proportion. Q hat is 1 minus P hat. And we are using the normal distribution in this estimation. We know this because we have a z value. So once again, we're following the same schema. We're adding and subtracting the margin of error. The margin of error is represented by this quantity here. So it's p hat minus z sub alpha over 2 times radical, keep everything inside the radical, p hat times q hat n. And we replicate the process on the right side, but with the plus. And then finally, we can also estimate the minimum sample size for a proportion. The formula is n equal to p hat times q hat times z sub alpha over 2 divided by the margin of error e, quantity squared, but we have to be very careful because there are instances where the p hat is not given. In those situations, we would use p hat equal to 0.5. That's our standard value. Thanks for watching the video.